Hey, good morning, afternoon, or evening, everyone. Welcome to the Shifting the Paradigm, Discover, Access, and Process Data with Cloud-Based Services Earth Data webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Savings Time, so let's go ahead and get started. I will begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any issues or you have any questions, please enter them into the Q&A panel rather than the chat located on the right side of your screen. Today's webinar is being recorded. The recording will be posted to the NASA Earth Data website as well as to our NASA Earth Data YouTube channel within a week of completion. Once completed, I will send an email to all registrants with the recording links and also a link to the presentation slide deck used in today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and demonstrations and an additional 15 minutes for the question and answer period. Now what I'd like to do is take a moment to introduce both our speaker and our Q&A panelists for today. During today's webinar, our speaker is Dr. Jeffrey Stano, the Global Hydrometeorology Distributed Active Archive Center, or GHRC DAAC scientist. Joining him during the Q&A session at the end will be Will Ellett, a principal research scientist at the University of Alabama in Huntsville Information Technology and Systems Center, and Navneet Selvaraj, who is the lead developer for the Field Campaign Explorer tool that will be featured within the live demonstrations. Our speaker will begin this afternoon's webinar with an introduction to the cloud-based services. Let me just pull up the agenda really quick here. And their connection to NASA goals. And then from there, we will provide an overview of enterprise services to include Earth Data Pub and the bulk downloader. After this, he will switch gears to science enabling activities and showcase the Lightning dashboard and provide a live demonstration of the Field Campaign Explorer. Once our speaker has finished with his presentation and live demonstration, we will then transition to an optional final set of polling questions. And usually I give these questions approximately 5 minutes or so before transitioning to the Q&A session, but the questions will be open much longer for those of you who might like to provide feedback. And then from there, we'll move directly to the Q&A period. Depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes from end time for those of you who wish to stay on the line, with a hard cutoff of 3:15. Just a quick note regarding the Q&A period. We will try to answer all questions within the time allotted, but if we are not able to address your question during Q&A, our speakers will be able to follow up with you offline. With that, it is my pleasure to introduce today's speaker, Dr. Jeffrey Stano. Jeffrey, and at this point, Jeffrey, let me go ahead and stop sharing and toss the presenter role down to you.
Jennifer, thank you very much. I will get things swapped over right now. And you should be seeing the slideshow at this point. So Jennifer, thank you very much for that introduction and also for all the help with your group getting this organized. It's always enjoyable to do this, and so thank you very much for your time and help. At the same time, too, I'd like to thank everyone for attending here today. And for any presentation of this magnitude, it always takes a lot of effort from not just myself as a speaker, but from a whole team of individuals. And so I would like to thank all of my colleagues who have been involved in this presentation, providing information and helping put this together. So thank you to all of you for your help here. So I'll move in to start off right now in terms of what is the goal for this presentation? What do we want to talk about today? The first thing I'll do is I want to speak about the Global Hydrometeorology Resource Center, or GHRC. We are a distributed active archive center. One of our roles is that we serve as one of 12 DAACs to archive Earth science data for NASA. Now that mission is evolving as we speak. Currently, we've been focused as curators of data for this Earth science data. And generally, this has been meant as a general role, a generalist type of role. However, NASA would like to see us become more specialized within our particular communities that we work with. Each DAAC has kind of an individual expertise, and we are being focused on becoming more specialized within that role. In addition to that, I'll be emphasizing GHRC's cloud expertise. We've been serving as a pathfinder for the DAACs to move into a cloud environment since 2019, and we were the first DAAC to move into the cloud. And so this has been an opportunity to leverage our cloud expertise for the various discussions that I'll describe below. Does. Now, the way I want to break up this presentation is into two parts, beyond talking about just what GHRC is. The first is enterprise services. So essentially, these are capabilities and features that are available across all of the DAACs. And there are two things I'll talk about today on that. The first is Earth Data Pub. This is essentially how do we receive data from data providers? So how does a scientist or someone who has done some sort of effort get these data to a DAAC? Additionally from that, we'll talk about the bulk downloader. So this is kind of after you've worked with getting a data to the DAAC and you've published data, how do you then access these data from other users and from the DAACs? Now, each of these are both kind of interesting because these are going to be our first steps to getting data into the cloud. And that's a major technology change for all of the DAACs, not just GHRC. We're going from having local servers at our individual DAACs to now working with this cloud-based server to store data for these archives. At the same time, too, once you can get these data into the cloud, this is what enables us to start doing more science-related activities. And then that ties into the last set of bullets here, which is the Science Enabling Center. GHRC is going to primarily focus on lightning activities. That's one of our key core data sets that we work with, and I'll mention that later on today in the talk. The tools that I'll mention are going to be the Lightning Dashboard and the Field Campaign Explorer. Both of these are designed for visualization and analysis of data sets. And this is where we're going to try to work with the user community to create tools and create systems that enable them to start doing science, not just with these data, but potentially science in the cloud as well. Beyond that, there's also the larger activities that are going on within NASA itself. One of the main pushes with NASA, and this is going to be a major emphasis for the upcoming year, is open science and open source activities. And I'll read the slide here directly to kind of make sure I get this stated correctly. But open science, as NASA is defining this, is a collaborative culture empowering the sharing of data, information, and knowledge to the science community and wider public. So in many ways, it's kind of what the DAACs are doing to start with our core missions. Again, we're serving as a location with which the user community can access data from NASA Earth science activities. But what this open science is trying to do is more than just simply providing data to the users. We want to kind of evolve this mission for all of the DAACs to leverage the new technologies and capabilities that we can see within the cloud. One of the easiest things that we work with right now is open source science. And essentially, this is where, again, I'll quote, sharing software, data, and knowledge as early as possible in the scientific process. One of the ways that GHRC does this is with the tools and capabilities that I'll be showing in the next several slides. All of these are open source in the sense that the code is available to the public to look at and to actually then enhance and modify in the future. So there's this nice expandability and extendability that is out there. So overall, this open science, this is an effort that we're going to continue to focus on as we move forward to kind of focus on these NASA goals. And I'll talk a little bit about the open science efforts and the open source efforts with each of the subsequent systems that I'll talk about here today. So as we start shifting gears here, I'd like to give a brief overview of the Global Hydrometeorology Resource Center Distributed Active Archive Center, or GHRC DAAC. So what is the DAAC? What is GHRC? Our role, we are one of 12 DAACs distributed across the country serving NASA's Earth Observing System Data and Information System, or EOSDIS program. Our goal and our mission is to make sure that we can process, archive, document, and distribute NASA Earth science data to the user community. We are aiming to focus on both past events and current and ongoing Earth science observations. So this is kind of an ongoing effort. There are numerous field campaigns that occurred kind of in the early 90s and things like that that are working to be brought into a DAAC. but also DAACs are working with real-time data sets. In particular, the Global Hydrometeorology Resource Center, we're working with the International Space Station Lightning Imaging Sensor. So this is a near real-time instrument. We're both archiving the full data set, but also making sure these near real-time data are available to our constituents. So the overall goal of the DAACs is to make sure these earth science data are available to end users wherever they may be and without charge. So more about the mission here. GHRC in particular, we are aiming to provide a comprehensive archive of data and knowledge augmentation services, and our focus is on hazardous weather. We're looking at the governing dynamical and physical processes, as well as the associated applications. Kind of drilling down a little bit deeper, our emphasis is with tropical cyclones, field campaigns, storm-induced hazards, and lightning. What's kind of interesting with the DAAC holdings here at GHRC is that we have a large emphasis on field campaign data sets. So we work a lot with ground-based data sets, airborne-based data sets, as well as satellite-based data sets. And that kind of creates some interesting complications, if you will, if you're trying to do science with that, because all those different data sets have their own unique qualities and characteristics. Now, this little timeline here shows just a few of the field campaigns we have been working with over the past 6 years or so. And our overall data holdings, as I mentioned, cover precipitation, hurricanes, storm hazards, lightning, and field campaigns. Also, one of the unique strengths of GHRC is that we were the first DAAC to transition to the cloud. We've been serving since 2019 as the pathfinder for the other NASA DAACs to transition into the cloud. So a lot of our effort has been to kind of develop the workflows, develop the capabilities of how do we start working and operating as a DAAC in the cloud. So with that kind of background as to what we are doing as a DAAC, let's start talking about some of the capabilities that we are developing utilizing our cloud expertise, and how do we potentially support this with enterprise services and these science enabling centers. The first one is going to be the Earth Data Pub system. Now, this is going to be a collaboration between GHRC DAAC and the Oak Ridge National Laboratory, or ORNL DAAC. And I'd like to make sure that I thank our collaborators up at ORNL, Dane, Kimberly, and Tammy, for their efforts with the Earth Data Pub system. So a little bit of background about Earth Data Pub. One of the things that the DAACs are now facing are several challenges. This is because the types of data, the diversity of data that we are receiving is growing. We see this with different aircraft, new instruments are being created, new capabilities are being developed. At the same time, too, these data sets are growing in volume, growing in size. And so those create unique challenges for the DAACs with which to, how do we handle these issues? And also, this is a good thing though, there's a greater number of data providers. So you have new researchers conducting efforts, new field campaigns that are out doing unique science and discovering new capabilities. This is a good problem to have. So this greater number of data providers. But at the same time too, that does mean as a DAAC, and not just for GHRC, each DAAC, we have to adapt to address all of these changes. One of the ways that we have done this, both at GHRC and other DAACs, is to establish a data publication workflow. In essence, this is a process with which we go from receiving data from a primary investigator all the way to a final publication where there's a data set that's accessible to the public to work with. Now, a couple of these workflows, they have been designed multiple different ways to address unique issues and problems that had to be addressed. At GHRC, we've created DAPR, which is a data application portal. ORNL has worked on a system called SOS, or the Semi-Automated Workflow Solution. And other DAACs have other capabilities and other workflow systems to address these types of issues and concerns. Now, the problem here is that the result of these different software systems to work on the workflow is that the experience can differ between DAACs. That's not a huge concern, but as you start working with multiple PIs of data sets, multiple data providers, if they need to work with more DAACs than just one DAAC on a regular basis, that might become troublesome because the user experience is going to be different between DAACs. How do they start processing the data? What is the terminology that they use? All of those things are going to be a little bit different. So the solution now is we need to have an enterprise level interface between all these DAACs. So I'll back up here and just once again mention what is a dataset publication. And this is part of the whole data lifecycle that the DAACs focus on. It's how we address receiving data, process data, and then make sure these data are released to the public. But also, given the mission of the DAACs, we are here to maintain the long-term management of these data sets. So the idea is not to have a data on the web on a web page for a short period of time. We are working to enable that these data sets are available to be used well into the future. That enables us to keep with key tenets of what NASA wants to do with Earth science data, which is reproducibility and being able to go back and revisit these data sets time and time again. So these activities that we create to publish data sets or workflows can vary between data producers and various DAACs. The task involved is quite varied. We have to do a number of different things. And initially, before we even receive the first data set, we're in this planning stage at the top. We are working with the data providers. We need to know how many data sets are coming to us. We need to know the volume of data. What's the data format, the file format? What is the file naming convention? We need to make sure that we can assess the metadata, the provenance, other types of details about the data sets. So that's where we're doing this planning. We understand that data collection, and then we start drawing in the data to our local DAAC. That's when we start doing the analysis and data set preparation, prepare it for publication. And you can see that with the bullets on the left-hand side here. That's where we start extracting the metadata, getting details about where and when did the data set get collected. We want to do quality control checks to make sure that things are lining up as they should be. We also make sure that there are supporting documents, user guides, possibly microarticles that we work with. And another major tool is to make sure that we can do a DOI assignment or a digital object identifier. This is a web link that identifies that particular data set exclusively to that particular web link, so you can easily access it. And then finally, we publish it. And so what Earth Data Pub does, it comes in between this planning and data collection process. It's that interface between the data provider and the DAAC. So on the right-hand side here is just kind of a basic screen capture of what the interface will look like with the Earth Data Pub dashboard. We're seeing data sets with some integrated data sets from iMerge. Let's see a couple other things that we're bringing in and just showing how is the workflow being addressed. And the advantage of what Earth Data Pub does, it creates this single central deployment within NASA's Earth Data Cloud system. This workflow allows us to monitor and track the entire process of where the data sets at right now, where in the publication process are they located. At the same time, too, the nice thing about Earth Data Pub is that it's extendable. So even though we have the ability and we have to pay attention to making sure there's a unified interface for all users, you can still have custom workflows for each DAAC to address unique capabilities of the various data sets. And as this is kind of we want to make sure this is cloud-based, we want to make sure that we incorporate modern programming principles so there's interchangeability of the modules to that way we can extend Earth Data Pub into the future. So overall, what is Earth Data Pub solving for us? It's a common front-end interface. It creates this enterprise-level interface for data providers. So it's a streamlined experience no matter which DAAC you're working with. It's the same user experience. We also make sure that the terminology is identical across DAACs, and it streamlines the dataset publication process. Now, there are several ways to access Earth Data Pub once this goes live. If you go to the NASA Earth Data website, you can start requesting to publish a data set. That's what will take you to Earth Data Pub. You can go to the individual DAAC websites where you can learn about the dataset publication process. Once again, submit a data accession request, and then go straight to Earth Data Pub, where you can make these requests and get access to the dashboard. So where are we going in the future with Earth Data Pub? Right now, we are in the early adopter process. So the early operations have begun. We're going to be supporting the onboarding process for multiple DAACs. Right now, ORNL and GHRC, we're in the first steps to kind of onboard Earth Data Pub right now. As this occurs, we'll be working to improve the workflow process and make sure that we expand the documentation for the future here. Lastly, we want to make sure that as time goes by, we expand beyond this minimum viable product and start getting other capabilities in here. So now the next enterprise level tool that I'd like to discuss is the bulk downloader. So what is this? What is the background for this? One of the issues that we face with the user community is that FTP is being replaced with HTTPS systems. So file transfer protocol, FTP, and then with the kind of the web interface, the HTTPS. That's kind of a major change. Many people have been familiar working with FTP over long periods of time. This results in some problems trying to access and download large data sets. And large data sets can mean both in total volume as well as number of files. So we need to be able to work to get access to all of the holdings of a DAAC, which are more and more moving into the cloud, and make sure this is through NASA's NGAP system, or the NASA General Application Platform, which provides a secure interface to NASA's cloud system. So all of this is operating within with the NGAP system. This is using the Amazon Web Services as kind of the overall system here. Now, with the bulk downloader, as I've mentioned, all the tools that we're discussing here today, they're cloud-based. It is open source. And what's nice about this is you can do one-click downloads. You don't have to try to do multiple steps. You say, I want this data set, download. We also can make sure that this supports multiple web browsers. And this is tied into the Earth data login. Again, that's kind of your key access to all of the NASA systems, whether it's Earth data search, Earth data pub, and also through the bulk downloader through here. Now, as I mentioned in the previous slide, because it is open source, this enables access to the archive data in NGAP, and we can get large volumes of data at a very relatively quick process. Now, this example here shows the bulk downloader interface in Earth data search, and you can see through here multiple things that you can look at. You can see this progression bar through here to show how far your data is coming in that download process. It shows where you're downloading your data to, and also can provide you information as to whether or not the download failed. If it failed, it will provide some information as to why that failed. So overall, the idea behind the bulk downloader is to make it easier to access and retrieve the data that you want to receive from any of the NASA DAACs. So as we move forward with this bulk downloader, we are aiming to get this released by the end of the fiscal year. And as we start extending support into the future, we want to expand the amount of browsers that this has access to, which is primarily some of the Macintosh systems, Opera, Safari, and other web browsers as we go forward. Now with that, I'm going to start shifting gears now from the enterprise service tools that we've just mentioned, Earth Data Pub and the bulk downloader. And I would like to start shifting gears into kind of more of the science enabling type content that GHRC is developing. Both these science enabling capabilities, these are again going to be cloud-based and working with that technology that GHRC has been focusing on for the past several years. So let's talk a little bit about what GHRC is doing with Lightning data. Lightning is a flagship data set with the GHRC DAAC. In the past several years, we've had numerous cases where several of the top 10 data sets that are received by our user community are Lightning data sets. At the same time, too, the Lightning data sets that we have span multiple platforms, ground-based instruments, airborne and satellite-based instruments. The period of record is pretty extensive as well, dating all the way back to the optical line scan instrument from the 1970s, up through current instruments such as the International Space Station Lightning Imaging Sensor, or ISS-LIS, as well as information that we're working to publish right now from the Geostationary Lightning Mapper. These efforts are not just happening in a vacuum. We are working very closely with the Marshall Space Flight Center Lightning Science team. This is both in developing tools and capabilities to work with Lightning data, but we're also operating the ISS-LIS here at Marshall and with personnel from Marshall and GHRC at the same time. The image to the left here is a nice little image from the space station. I've circled in red here the instrument rack where the Lightning imaging sensor is located. So with that, the idea behind the Lightning dashboard is how can we kind of take all of this Lightning data that we have, and how do we move on and start working with these data? So it's not just, again, GHRC serving as a curator of data, but being able to start using and operating these data. So the questions that we have to address are, there are a variety of data sets. And these data sets are not very similar to one another in both file format and what they show. They have different domains. As you can see through here on the left-hand side, this is showing data from the geostationary lightning mapper that can show you kind of hemispheric coverage over the Western Hemisphere right now. There's also the International Space Station Lightning Imaging Sensor. This is a climatology display over the past 4 years of data. And what's interesting about this is it shows this kind of near global coverage, but since the International Space Station is a low Earth orbiting platform, you're only getting snapshots of data as it goes over a particular location on the Earth. So the geostationary lightning mapper provides you a continuous view. The ISS-LIS gives you kind of this snapshot over time. And then lastly, we are working with NASA's lightning mapping arrays. This here in the lower right-hand corner is showing the North Alabama lightning mapping array owned and operated by NASA. The lightning mapping arrays give you very high temporal and spatial resolution. They can map out the individual channels of lightning flash, and you can see a little bit of that through here, this flash extending southward from the core of the storm towards Huntsville, Alabama. The problem with the lightning mapping array is, unlike LIS or the geostationary lightning mapper, is that it has an extremely small domain, generally a radius of only about 150 kilometers from the center of the network. So as a science person myself, primarily working with lightning in the past, trying to access these data sets, visualize, manipulate, and do various research with them has been very difficult. You have to understand the individual data sets. You then have to understand the file formats. And all of that is time consuming. So what we're aiming to do here with this Lightning Dashboard is, can we provide some basic capabilities to jumpstart that research process, to help you find the right data set, look at some intercomparisons, be able to identify what might be some differences between the different lightning data sets that you can observe. So that brings us to the idea of the Lightning Dashboard. Right now, we're focusing on a minimum viable product. We want to have a basic visualization and some simple comparisons of observations. The other goal that we want to work with is that we want to make sure that we're leveraging cloud-optimized data sets. One in particular are cloud-optimized GeoTIFFs. Now, there are a number of advantages of working with these optimized data sets. For one, you have faster data load times. That's really helpful. And also, particularly since this is a tool that will be online, you don't have to download it to your local system. Because it's working in this GeoTIFF format, you don't have to download large chunks of data to load as you pan and zoom across a display. Also, this works better on HTTPS systems. You can handle large files better. And also, this helps in the zooming process. If you want to zoom in or zoom out, what occurs is that you have this internal tiling. So essentially, instead of downloading data as you move up and down in your zoom level, this internal tiling just works on the map coordinates. So it's a much faster and more integrated way of looking at data and displaying the data quickly for you. So what are we doing right now? We're working on the minimum viable product. Right now, we're aiming for 2 data sets, the gridded lightning imaging sensor climatologies and the North Alabama lightning mapping array. Our goal is to have this MVP ready by the end of fiscal year 22. As we go forward into the future, we want to incorporate additional lightning data. As I've mentioned at the beginning of this section, we have numerous lightning data sets available here at GHRC, and we would like to ultimately incorporate most, if not all of those, into the analyses. At the same time, too, the dashboard can be expanded in its capabilities. We work very closely with Marshall Space Flight Center's Lightning Science team, and we're going to be in close collaboration with them to discuss capabilities and ways to use this dashboard as we go forward. So again, it's one of those things where we want to engage the user community and kind of help develop that science enabling center here at GHRC for the lightning data sets. Now, as a quick sneak peek here, here's a quick sample display. What you are looking at right now is from the Tropical Rainfall Measuring Mission, or TRMM, lightning imaging sensor. So this was the predecessor to the International Space Station lightning imaging sensor. This is just kind of a quick demonstration to work with this instrument as we move on to the ISS-LIS. And what this is showing, it is showing the total climatology of all lightning observed in the field of view from 1998 through 2013 for all Januaries at this time of year, for all Januaries in this time frame. And that's pretty obvious that you can see that you're looking at a January time frame. That's winter time for the Northern Hemisphere. You go south of the equator, you're getting into the summer months for the southern hemisphere, and clearly lightning is active across northern Australia, much of Africa, and central South America. What you can see here on the dashboard as well, and just kind of these simple displays that we have, is that you can toggle various capabilities from the lightning imaging sensor, seasonal, monthly, or even diurnal climatologies. And you can also switch over to, say, the source densities or the flash extent densities from the North Alabama Lightning Mapping Array, or NALMA. So we'll continue to expand on this throughout the summer and look to release this by the end of this fiscal year. And lastly, I'd like to wrap up with the Field Campaign Explorer, or FCX. So what is Field Campaign Explorer? What is this trying to do? The concept behind the Field Campaign Explorer is that, once again, this is a cloud-based system to provide coincident three-dimensional displays, visualizations, and analysis of field campaign data sets. That is one of the big things we want to focus on, is that coincident display of 3D data. And here we have a live link. You can follow this link to look at these data sets and look at the FCX after the presentation if you like. So the question comes down to, why did we want to create the Field Campaign Explorer? What was the purpose of FCX? The issue that we face, particularly with field campaign data sets, is that they have numerous challenges. Much like, as I was discussing with the lightning data sets, you have multiple platforms. They come from ground, airborne, satellite-based data sets. And the variable fields that you have to address are quite varied. You have point observations, two-dimensional observations, both in horizontal and vertical, and also three-dimensional data sets. Plus, on top of all that, you have raw observations. You're trying to look at data sets that are derived from the raw observations. There's model output to look at. There's satellite observations. Other details about aircraft information, about the orientation of the aircraft as it's flying along, which has an impact on the type of data that are being received and observed. So FCX is designed to try to serve as an interface so that you have better data exploration and data analysis and data search capabilities for these types of data sets. Much like the lightning data, as I mentioned, trying to do research as myself as a lightning researcher, trying to look at these different data sets, FCX is intended to kind of serve as a way to help users focus on what's happening with the data and to look at them coincidentally, so that you can actually kind of start saying, hey, what are we seeing between these two types of observations? What's happening with the lightning data versus the radar data versus the ground observations that are all being collected simultaneously? So the goals for FCX is that obviously we want to kind of focus on science questions tied to a campaign. So this particular campaign that I'm showing here, this is from the GoS PostLaunch Test Field Campaign. This is a verification and validation of the new instruments, such as the Geostationary Lightning Mapper or the Advanced Baseline Imager on the US's new geostationary weather satellite. They're trying to identify what are the features, how does it work, how is it working with severe weather and other observations. But at the same time, too, we want this to be interactive in this three-dimensional sense, so you can mouse over, get information about the data that you're looking at. Ultimately, too, we want to make sure that this links you to additional information. It's not just simply looking at the data, it's full-fledged data exploration. You can get the background information about the campaign. You can get access to the user guides for the data sets. You can get access to microarticles that further explain the data through here. We also want to make sure that as a tool we're developing for FCX, that ultimately you can create a three-dimensional volume, subset that volume, and download and access that for your activities. Either you can bring that down to your local system, or you can do, as we call it, science in the cloud, kind of the NASA goal here for doing science in the cloud. At the same time, the architecture is not fixed. This is an extendable architecture so that we don't need to limit it to just field campaign data sets. In fact, it's one of the things I'd like to see GHRC do in the future. We're focusing on our field campaign data sets. I would like to see GHRC use FCX to help visualize all of our data sets. And again, this is already an open source system so that you can go to the GitHub repository and access these data, and you can create your own modules and potentially focus on your own data sets as well. Now, as I mentioned, it's an entirely cloud-based system, so obviously that means it's serverless. You don't have to download anything to your local system. You can do analysis in the cloud. So again, once you start putting in these analysis tools within FCX, you don't have to bring anything onto your local system and download it. And this is going to get more and more important as we go forward, because as all of the DAACs are working to bring more of their data into the cloud. The image here, again, shows just kind of a brief architecture of what's happening. This is all working within the Amazon Web Services. Here on the back end, we're taking the raw data that we have access to, and we're bringing that into one of two kind of cloud-optimized systems, either a cloud-optimized GeoTIFF or into the ZAR data format. And then that helps us working with the background tools like Cesium for the three-dimensional displays, and bring all this into the cloud, bring this into the web app, and then users can then access these data. The FCX system was open source released in April of this year. So that means any user can now go in and create their own application program interfaces or APIs for the system. So some of the capabilities I want to show here, and then I'll go into a live demo with the last few minutes. Some of the capabilities, you can toggle data sets on and off, pan and zoom. We can change your time and space for the temporal displays. And eventually, you do have the access to supporting documentation. And a nice little tool here as well in the lower right is this timeline view. You can show at what time were various data sets available. So you can see when data sets were overlapping with one another. So let me pause here real quick, and I'll bring up the FCX site. So what you can see here, we have two campaigns currently loaded. We have the GoS PostLaunch test field campaign, and just recently, the investigation of microphysics and precipitation for Atlantic coast-threatening snowstorms, or impacts. I'll start off with the GoS PostLaunch test. And as you see here, this will bring you in. It'll tell you a little bit of information about your visualization hardware that you're using on your system. And everything's being to load up right now. So what I will show in the next couple of minutes here, on the left-hand side, you can see the various data sets that are available. At the top, the advanced baseline imager. So that's just showing the cloud features. I can toggle that on, or off or on. There's information about the geostationary lightning mapper. So that's the yellow dots through here. And if I move over, as I move over those individual dots, you can see that that is a GLM lightning observation. It gives you the lawn location and how many raw events were observed, or how many times did light hit the sensor of the geostationary lightning mapper through there. At the same time, too, we have the ISS LIS. Those are kind of the aqua dots through here. And the other features, we have the cloud radar system. And I will kind of hold the mouse down, and then I can scroll in to zoom in. And you can see as we zoom in here, that feature kind of fills in. That's part of the technical cesium system in there, kind of that dynamic loading through here. So you can see that kind of that cross-sectional view of lightning data of the cloud radar system. And then these spidery little tendrils, these are from the Oklahoma Lightning Mapping Array, showing the individual lightning flashes. So let me do this right now. Let me turn off a couple of these features. So I'm going to turn off the cloud physics LiDAR, a couple of these data sets. I just want to show a couple of details through here, because now I can start moving around. If I hold the control button down, I can now look straight down. You can see where everything's moving. Again, you see the individual lightning channels. And also through here, you can see how the cloud radar system actually angled over time. As the aircraft was flying by, it has to bank. And you can see that the radar, instead of being a top-down view or being straight down, it then kind of angles off to one side. So we can go backwards in time, go forwards in time. I can pan around, and we kind of look at this kind of a head-on view, kind of a side view through here. We see the various features loading in at this point as we move around. And what's nice too is you kind of look at this, you can see how the lightning data, I know I'm trying to move slowly here with the loading and everything. You can see how the lightning data correlates to the radar observations that are being seen. Now, other things I can look at, I'm going to hit the pause button down here to kind of stop the movement in time. There we go. I'm currently in the data viewer. I can shift up and look at the timeline. And once again, this gives you all of the observations of the data sets that were available at any given time. At the same time, too, I can go back to the Field Campaign Explorer page. I can now look at the impacts field campaign.
And again, you can see the similar data sets that are being looked at through here. Obviously, this was the difference between impacts, that this was looking more at snowstorms versus severe thunderstorms. But I'm going to move over to the left-hand side. I'll expand things out a little bit. And you can get details about the campaign itself, about impacts. Here's the logo, and about just what is this field campaign doing. I can also click on links. I can take this link here to the landing page for impacts. And this takes you to the page that GHRC curates to give you all the information about impacts. Where did it take place? When did it take place? How can you cite the entire campaign? And then all the individual data sets. I'll close that link. I can also go down to here and click on data. And once again, this will show us all the data that are available in this particular time for the field campaign. I'll click on that. And that will take you to the Earth Data CMR search, the landing page where you can access directly the Cloud Radar system data. So with that, as time is winding down here, I'll wrap up with our future work. We want to continue our development with FCX. I want to see this kind of integrated more into our web page and get the analysis tools brought in, particularly the three-dimensional subsetting tool. We're continuing to focus on bringing in new field campaigns, in particular the Hurricane and Severe Storm Sentinel and the Olympics Mountain experiment. Those are both focusing on our precipitation and hurricane holdings. And I believe there's a lot of synergistic capabilities with other GHRC projects. In particular, the Lightning Dashboard. We're working with Lightning data in both. That's good capability. And also the visualization software that we develop for FCX can be spun off onto data recipes that we can do in a Jupyter Notebook feature for users if they want to just access the data individually. And so to wrap up here, this presentation really wanted to focus on a couple of the capabilities that GHRC is developing, focusing on our cloud technologies with an emphasis on user services. We've focused on enterprise level services to start. So that's Earth Data Pub and the bulk downloader. These are tools that are designed to create a unified system to both provide data to any DAAC, as well as to then quickly and easily access the data once it has been published. We're also focusing on kind of the Science Enabling Center concept. In particular, we're looking at our Lightning data sets, as I've shown with FCX and the Lightning Dashboard. How do we kind of enable the ability to use the data that we have held here, particularly with field campaigns with our Lightning data sets, to make sure the user community can get more out of these data sets, make it easier for them to access the data and do research with them. At the same time, we're continuing to support the other goals that NASA has laid out, which is open source, making the code freely available to the community, and open science, trying to better bring in the user community to the process so that we're not just simply a curator of data, but actually enabling the whole user community to be involved in the process. As we go forward in the future here, Earth Data Pub, we're working on the upcoming release and we'll be doing service updates and DAAC onboarding. Bulk Downloader, that will be released later this fiscal year as well with service updates. The Lightning Dashboard, we're aiming for the MVP or the minimum viable product release by the end of the fiscal year. And we'll be coordinating with the Marshall Space Flight Center Lightning Science team to develop and create some enhanced capabilities for analysis with the Lightning data. Lastly, the Field Campaign Explorer is already publicly available, but we are expanding the data access, adding our data analysis tools, and getting that three-dimensional data subsetter involved with this. And so with that, I'd like to thank everyone for their time today. I appreciate you joining and listening to our presentation. Be excited to listen to you to address your questions here. So thank you.
Okay, at this point, everybody, let's go ahead and transition to our Q&A session. We had a question earlier that I believe was answered in terms of speaking to the temporal and also the spatial coverage for the ISS list data. But if you could confirm the temporal coverage, that would be wonderful.
Yes, the temporal coverage for the ISS list that's currently extending from February 2017 through present, it does have a near real-time component to provide data updates every 2 minutes. Its spatial resolution is about 4 to 8 kilometers, depending on whether you're straight down versus kind of off to the limb of the instrument. And I believe Jennifer did mention that it does have a range from about 55 south to 55 north
Yes.
thanks to the orbital characteristics of the ISS.
Okay, thank you, Jeffrey. And then the next question is, are there currently official APIs available for direct access to GHRC DAAC data and for easy subsetting by time period, latitude, longitude, or parameter?
At the moment, officially, no. That is an excellent recommendation and suggestion to go forward with some of these things. So no, at the moment we do not. But that has been noted, and we're actually kind of chatting amongst ourselves with that right now.
Okay, thank you, Jeffrey. The next question is, are there code examples for the cesium viewers which can be explored with their with Sandbox and its CESU JJSs, excuse me.
Yes, according to my colleagues, Navneet, who's on the line here, if there's, in case I misrepresent anything here, Cesium has a sandbox called Sandcastle, where we can use the templates to visualize data there.
Okay, thank you very much. And Will and our other Q&A panelist, you should be able to unmute yourselves if you like to jump in at any point. All right, let's see. I'm actually not seeing any. Let me check the chat. Seeing any additional questions. Let me just go down a little bit here. Okay, and so the follow-up question is regarding any rough ETA on the API availability if that happens.
So I think we need to discuss internally about just what API availability even means for GHRC data. If are we talking about just, I mean, because our data is all within Earth Data Cloud and the capabilities within OpenSearch or Earth Data Search and any APIs that may be within that system. But as Jeffrey said, we don't have any APIs developed internally for access, and we really didn't have any on our roadmap, at least not right now.
Okay, thank you, Will. All right, here. Just scanning to see if there are any additional questions. Okay, one of the questions was, although it's not particularly specific, but the question is, how can I download the spatial data? There are probably numerous ways, but I'll let you see if you can provide more explanation. And maybe if this user wants to provide a bit more clarification as to any specific data sets, but I leave it to you, Jeffrey, or any of the other panelists to provide additional feedback on that. If you're speaking, Jeffrey, I actually can't hear you.
That would be important to unmute to do that. I'll start straight out of the Field Campaign Explorer, although an individual can go to Earth Data Search to access data as well. Essentially what you can do, you can click on individual data set. You can also go to the GHRC or other DAAC website and do find data through there. And that will ultimately bring you to kind of the Earth Data Search site, which will give you access to where you can see the data. In this particular case, we look at the Cloud Radar System from the Impacts Field Campaign. This is the overview page, and we can go look at documentation, get information about the user guide. So you can see that, or I'm sorry, that's the website through there. Then go to the user guide as well, another PDF to give you details about this. But the user was asking particularly about downloading data. So I can go straight to download data. And I go straight to this link. That brings me straight into the Earth Data Search. And now I can say, okay, I want to start accessing data from GHRC, look at the Cloud Radar System. So we have 1, 2, 3, 4, 5, 6. There were 6 flights for this particular campaign of this instrument. I can do a download all to start trying to bring the data sets into the system. So essentially, where you want to be going is Earth Data Search. but you can reach Earth data search through multiple paths. Through the DAAC, if you're looking at it from FCX at GHRC, you can look at it through there. And ultimately, it all brings you into the Earth data search system here. And you can look at a couple of different ways, like do a direct download, configure the dataset customization, things like that. Hopefully that helped address the question there.
Okay, thank you, Jeffrey. Let me scan to see if there are any additional questions in the Q&A here. I do see that there are. Okay, so the user is asking if you can copy the link that you were just using into the chat, please, Jeffrey.
Certainly. I will pull up Earth data search directly and bring that over for you.
So I've added the GHRC. If it's just a matter of Earth data search, I can put the link here as well.
Oops. Jennifer, thank you. I had it there, but it was not letting me send.
Yes, so in the Q&A panel, we have to respond to a question. You'd have to use the chat for that, but I think we're covered. Hopefully everybody should be able to see that. And let me actually...
But yes, I apologize.
Oh, that's okay.
Yes, Earth data search is kind of the central clearinghouse for where everything is going. And if you go to the GHRC webpage, another DAAC webpage, if you're on FCX, all of these things will direct you to where the data are located on Earth data search.
Okay, perfect. Thank you, Jeffrey. All right, let's see if we have any additional questions. I am scanning and let me check the chat one more time. I don't see any additional questions within the Q&A. Let's see here. If there are no further questions, then we will end this afternoon's webinar. I'll leave the polling questions open an additional 15 minutes. And if there are any comments from our speaker or our panelists, we can address those now. And if not, we'll log off from the audio component, but we will leave the virtual meeting space open in case you think of something. And I do want to add that anything that we did not address during the webinar timeframe, we will forward to our speaker and panelist, and they will be able to address those inquiries with you offline.
Yes,
All
and
right.
Jennifer, thank you very much for everything. And certainly appreciate all the comments and questions that came out. I think there were a number of good things that came out and definitely some stuff that for us to think about here on our end to kind of add to what GHRC does.
All right. Well, thank you, Jeffrey, and thanks to our panelists. And at this point, we will log off from the audio components, and I'll leave the virtual meeting space open.
All right, thank you very much.
Thanks so much, everybody. We hope to see you at an upcoming webinar. Take care now.
Take care.
All right. Goodbye.